Hello friends, our today's topic is limit. Let us take a function y equals to twice x, and all of you know the graphical representation of this function is like this. The values of y is twice of x. Now for a particular values of x, suppose x equals to 1. If I consider x equals to 1, then the functional value of x is coming 2. If x equals to 1, then y is coming 2. So this is 2. Now let us take some values of x. Since x is a variable and y is x equals to 1, 1 is a constant. That means 1 is the particular values of x. Now if I take some values of x which are very close to 1, maybe from the left hand side or right hand side. Okay, if I consider the values of x from the left hand side, suppose x equals to 0.9, x equals to 0.9, then the values of y for this 0.9 is coming 1.8. So if x is 0.9, then I am getting it is this 1.8. So this point is 1.8, which I am getting for x equals to 0.9. Now if I move from 0.9 very close to 1, suppose the next point I am taking now 0.99, which is very close to 1, and for this 0.99 we are getting the values of y is 1.98. Now let us take more close to the point x equal to 1, say it is 0.999, 0.999, and for these values of x, the value of y is coming 1.998. That means one thing is clear from these values of x and y, that if x moves from 0.9 towards 1, very close to 1, then the values of y also moves towards a particular value, and that particular value is 2. See, x moves as much as closer to the point 1, y moves very close to the point 2. So this we can write in this way: limit x tends to 1 minus. Why I have taken 1 minus? This is because of x is moving towards 1 from the left hand side. Now the functional value fx moves towards the point 2, and that is called the left hand limiting value of the function fx, which is 2. So if we move now x, the values of x towards 1, but from the right hand side, then let us see how the functional value of this moves towards which particular point. So for that, let me take x is suppose 1.1. If x is 1.1, then fx is coming 2 into 1.1, that means 2.2. Now if I move, suppose this is 1.1, and for this 1.1 I am getting the point is, it is 2.2. So this point is 2.2. Now if I take this x, variable x, which is very close to 1, say it is 1.01, it is very close to 1, and then what it comes, it is coming 2.02, 1.001, it is coming 2.002. That means here is also, this is clear that if x moves towards the point 1 from the right hand side, then the y also is moving towards the particular point 2. So, and that we can write x limit x tends to 1 plus. 1 plus means x is very close to 1 but greater than 1. That is, x moves towards 1 from the right hand side. And for this values of x, the functional value of fx is coming 2. So this is called the left hand limiting value, and this is called the right hand limiting value. So for both of this we are getting the same value. That means x moves towards 1 either from the left hand side or right hand side, the fx moves towards the same point too. Now since the left hand limit and the right hand limit both are same, we can say that the function fx, its limit x tends to 1, fx exists, and the limiting value of the function is 2. So when the left hand limiting value and the right hand limiting value are same, then only we can say that the limit exists. I will show you some examples where you will see that the left hand limit and the right hand limit, they are not same. So in that case, we will say that limit does not exist. So the example that I have taken here, that y equals to twice x, at x equals to 1, its limit exists. Now I am going to take an example to show you that the limit may not exist at a particular point. Suppose I am taking here y equals to mod x. This means what? This means y is equals to x if x is greater than or equal to 0, y equals to minus x if x is less than 0. And if we draw the graph of this, then we have this. So here if I take x equals to 0, then fx is what? Fx is also 0. Now if I take x is very close to 0, suppose limit x tends to 0 minus fx. So if x is very close to 0, that means x is less than 0. So if x is less than 0, then I will take y equal to minus x. Now minus of less than 0, how much it is close, but it is less than 0, that means the value is negative. So negative of a negative number, that means it will be positive, and that is very close to 0. So this we can say it is 0. Now if I take the right hand limit, x tends to 0 plus, this means what? That x is very close to 0, but it is greater than 0. So in that case also, suppose x is very close to 0, say it is 0.001. So y also same 0.001. So how much it will move towards x equal to 0? Fx also will move towards 0. Suppose if I take from the negative side x equals to minus 0.001, then fx also same plus 0.001. How much it moves towards the point 0? Fx also move towards 0, either from the left hand side or right hand side. That means we can say that left hand limit and right hand limit both are same. So we can say that limit x tends to 0, fx exists, which is 0, which is 0. Now I am going to take another example to check that the limit exists or not. Here fx equals to mod x by x. Now clearly since the denominator contains x, so x is not equals to 0. But what is the value of fx when x is 0? Okay, let us define it like this way. Fx equals to 0 when x equals to 0. As we cannot take 0 here, so that's why I define it like this way, that fx will be 0 if I take x equal to 0. And other than 0, fx is mod x by x. Now if you draw the graph of this function, then it is, here I'll take some positive value and some negative value, x, and this is fx. So for any positive values of x, whatever I'll take, x, mod x equal to x, so mod x by x, that means it is 1. So whatever I am taking, suppose x equal to 1, 2, 3, whatever be, fx is what? Fx is 1. This is also 1, this is also 1. As I am just showing you here, x equals to 1, so mod 1 means 1, so 1 by 1, that is 1. X is 2, so mod 2, that is 2 by 2, that is also 1. X is 3, so mod 3 by 3 is 1. So whatever value I am taking means all positive values of x, fx is coming 1. Now if I take some negative value of x, suppose -1, -2, -3. Now for -1, mod of -1 is +1, 1 by -1 is -1. If I take -2, then mod of -2 is +2, 2 by -2, that is also -1. If I take -3, then -3 is +3 by -3 also -1. So whatever I am taking for any negative values of x, fx is coming -1. So the graph is like this. So what we can write, that limit x tends to 0 or whatever be, suppose 0 plus, I am going to check the limit of the function at x equal to 0. So that's why I have taken limit x tends to 0 plus. That means x is very close to 0 but it is greater than 0. So in that case the value of the function is coming, fx is coming +1. Now if I take limit x tends to 0 minus, then the value of the function is coming -1. Whatever be, if it is less than 0, so for all less than 0, the value of the function fx is coming -1. That means here clearly we can see that the right hand limiting value is 1, whereas the left hand limiting value is -1. So left hand limit and right hand limit does not match, so they are not equal. So we can say that the limit of the function, that means limit x tends to 0, fx does not exist for this function, and the value of the function fx is 0. Here this is the value of the function on exactly x equals to 0, and this is the limiting value. That means when x is not equal to 0 but x is very close to 0, then the value of the function for left hand limit it is coming -1 and right hand limit is coming +1. Now the last part here I am going to tell you that what is the difference between this limit x tends to a and fa. Limit x tends to a, fx and fa. So right now only I explained you that this is the limiting value. That means when x is very close to a, either from the left hand side, that means x is very close to a but little less than a, then the value of the function, that is the left hand limiting value. Limit x tends to a plus fx. Here is the value of the function when x is very close to a but little greater. How much close to a, but the value of x is little more than a. Then what is the value of the function? That is the right hand limiting value. So when the left hand limiting value and the right hand limiting value are same, then only we can say that the function limit x tends to a fx exists. So these are coming the limiting value, not the value of the function exactly at that point. Now the function fx, I want to find out that what is the value of the function exactly at x equals to a, not for the very close to point a. For very close to point a, that I am getting here left hand limit and the right hand limit, but exactly if I put x equals to a, then fx is, what is fx? That is fa, that is the value of the function. So this is the value of the function when x is a, and these are the limiting value of the function when x is very close to a from the left hand side and very close to a from the right hand side. When these two are same, then this limit x tends to a fx exists. So this is the limiting value of the function and this is the value of the function exactly at x equals to a. Thank you.